Hi all. So, we are switching gears. We are talking about a new technology, maybe an old technology, a technology that is inherently... It's not this technology, I promise. This... It's globally accessible. It is fully decentralized. It is fitting for any purpose, really, and is fully individualized. It scales from the nanometer scale all the way to the kilometer scale, and on top of that, it is dead cheap. You can maybe spot it on this image right here. It's the potted plant. It's nature itself, really. So nature is going to fuel the next technological revolution. To understand how that will play out and why, let's take a step back and look at technological revolutions of the past, starting, of course, with the Industrial Revolution. So that was a time when we sort of decoupled the forces that we can use to create stuff, to grow, from our physical muscles and the muscles of animals like horses. And we actually managed to unleash power, really. So in essence, what the Industrial Revolution did was it transformed energy and scaled it to unprecedented scale. Moving on, another 100 years or so, there was the Digital Revolution, obviously. With the advent of the personal computer, the internet, we unleashed knowledge, basically. It's literally at our fingertips now. So in its essence, the Digital Revolution was a transformation of information, really. And now I'll come to the next technical revolution, which I call the Biological Revolution. And maybe you already know where I'm going to go with this, because you've been here for 2 days. So this is really a revolution about unleashing physical substances at atomic precision, basically. So the Biological Revolution will be a transformation of matter. So we've been talking about the Metaverse and the Matteverse for the past 2 days, and we talked about two forces that pull into opposite directions, with the Metaverse sort of leaving off into purely the digital realm, whereas the Metaverse is more like transforming matter from within, right? There's, however, one concept that they have in common, and that is that they're both codified. So the Metaverse obviously is coded in zeros and ones, stored in transistors, whereas the Matteverse is coded in physical atoms and in its biological flavor in genetic code, in DNA. I've been a bioscientist for 10 years, and I've learned to use DNA to understand how to write it in such a way that it actually carries out a certain functionality, and much smarter people have done similar stuff over the past 2 decades. And really, we now are at the brink where we turn from bioscientists into bioengineers, finally into biodesigners, and we can come up with these cool ideas that take biology as we can engineer it from the microscopic scale to the macroscopic scale. And I guess the question now is, how will that look like? And you've seen amazing examples yesterday of that already. I'm less imaginative, but luckily we're in the beautiful city of Barcelona, where people over 100 years ago already took inspiration from nature to change the way we build stuff. And this, you know, what Antoni Gaudí did is not only, it doesn't only look nice, it has added function in terms of the stability of the buildings, the residential buildings that he designed, but also air circulation, things like that. So it makes sense. So imagine a genius of the likes of Gaudí with a technology of bacteria that can grow cement in situ, in that specific place, reinforced with biosynthetic spider silk. How would that look like? Maybe something like that. Let's think about fashion. Imagine a jellyfish-inspired dress, but it's not only inspired, it actually contains proteins from jellyfish that make it light and floaty and colorful, or a running shoe made of fungal mycelium with the bounciness of mushrooms, you know? Or we had an amazing representation of this intersection of electronics and biology. How would that look like? There's already spinach that can send you an email when it's stressed. Or let's say we want to make the most inhabitable places on this planet habitable. And maybe not only on this planet, but also in space. Payload to send it up and away from this planet, to take it away from gravity, is super expensive. Imagine all it takes is only one cell and a bit of code so that an astronaut can basically produce everything on site in space on a different planet. So these are the cool products that are imaginable. But what's maybe more important are the changes in our mindsets and the changes in societies. And for that, let's again take a step back and look at the technological revolutions of the past. The Industrial Revolution has brought us unprecedented growth, right? But it came at a cost. It led to the deterioration of this planet, really, and what that sparked was an intergenerational conflict that I guess we all can only assume will get worse. The digital revolution has connected us all, except for maybe the bottom 1 billion on this planet. It has filled the knowledge gaps, but did it really fulfill us? So I want us to anticipate what the biological revolution could look like and make sure we can shape it in a way that it really benefits all of us. What that means for me is to sort of rediscover respect for nature, to see concepts of diversity and change, which are like inherent powers and concepts of evolution, to see those as features and not bugs. And because we can do it, to make it really equitable and fair, because nature is equitable and fair. If you want to talk more about the biological revolution or real-world examples that already exist, please reach out to me. Thank you very much.